Cal Poly's Payload is essentially a data acquisition system. So it's a tool that they can use to understand the flight, understand what's happening in flight, understand how their payload is performing and so on. And this is such a great experience for students to take the academics and bring that into the real world. Aurora is so transformative for students and researchers because there's a huge difference between a hypothesis to a lab test, and then lab test to real world functioning. Often university can be quite stuck in those first phases, but by flying something on Aurora, you can go from your hypothesis all the way through to flight proven. That's just totally transformative.
Countdown is with you, Iago.
5, 4, 3, 2, 1. By prop.
It's great to be able to fly payloads for students and help them learn about aerospace and understand how to really get something from the academic side of things and the theory to actually building it and flying it and actually making something work in the real world.
Hello everyone, my name is Dr. George Nield. I'm currently serving as the chairman of the Global Spaceport Alliance. I'd like to welcome all of you to the GSA webinar on Spaceports as academic partnerships. I also want to thank our sponsors for the year. Our 2026 title sponsor, RS&H, Platinum sponsors, Merrick and BRPH, and Gold sponsor, Parsons, along with our 2025 sponsors, ITA, HDR, and MITRE Corporation. Just a reminder, coming up at the end of this month, we've got the second annual GSA International Spaceport Forum, which will be taking place in Sydney, Australia, the day before the International Astronautical Congress, which is being held there later in the week. There's still a few seats left, so if you'd like to participate in that, please sign up on the registration form that's available on the GSA website. Also want to alert folks that registration is now open for the GSA Spaceport Summit, which will be taking place on January 27th in Orlando, Florida. And of course, the summit is part of the Commercial Space Week that goes on in Orlando, which includes not only the Spaceport Summit itself, space mobility, and SpaceCom. So check that out and feel free to sign up. We have some upcoming events to share as well, and our next webinar will be October the 1st with the topic of ocean launch. And if any of those appeal to you and you're not already a member, please consider joining. More information is available on our website. We'd love to have you join the Spaceport ecosystem. So as I mentioned, our program today as its topic, academic partnerships, the key to local spaceport success. And we believe that spaceports thrive when they're supported by strong academic ecosystems that serve the full talent life cycle, from early STEM education to workforce development and ongoing professional training. So we're planning to explore how strategic partnerships with universities, community colleges, K-12 institutions, and other educational organizations can drive long-term success for spaceports and their surrounding communities. Specifically, we want to highlight how those partnerships can help spaceports to build local talent pipelines, support tenant needs with continuing education and workforce upskilling, and inspire future generations through K-12 STEM engagement. We've got an outstanding panel today, which includes James Powell, Chief Engineer and Co-founder of Dawn Aerospace, Dr. David Alexander, Director of Rice Space Institute, Dr. Sarah Janes, Associate Vice Chancellor of San Jacinto College, and with her is Clinton Harris, Training Coordinator for San Jacinto College. We have Liz Kennick, CEO of Teachers in Space, and Matt Voss, co-founder of Near Space Education. So why don't we start off with James Powell from Dawn Aerospace. We saw the video during the introductory slides that were put up. I think this is an outstanding example of real-world activity and partnerships that are already starting to grow with the academic community. So welcome, James. Please share your thoughts on how other folks could take advantage of this type of an example.
Yeah, sure thing. First, thanks for the intro, Dr. Nield, and great to be here, and great to be a part of the Spaceport Alliance. Bring another part of the world to the team. As you will have seen in that video, great example of one of our research payloads that we flew with Cal Poly, who I'm sure you'll all be familiar with out of the States. Just to start off, let's just quickly go through a flight and how we do a flight with a research institution. Here we see our aircraft, the Mark II. This is our A version, and all on the runway, ready to go. But just to kick things off, sort of thought, get some context and start off, where are we? So down here in New Zealand, nice part of the world to do this sort of research and flying and so on, because we've got all of this ocean out here with no one else in it. And that means that we've got lots of clear airspace, very low traffic density, very low population density. And this means things like flight windows and flight corridors and all that sort of stuff are just hugely opened up compared to places where there's a lot more activity, such as the US. But anyway, specifically, we're based in Christchurch in the South Island, and then where we presently fly, Tawhaki National Aerospace Centre is about an hour south of Christchurch, just on the coast. So nice and convenient to our main headquarters in Christchurch. And here we see this is the aerospace centre there. So in many ways, actually, lots of similarities to Cape Canaveral, but just our much smaller New Zealand version, where we're sort of out on the coast, out on a bit of a peninsula, with not too much around. So just like any aircraft, we start off with pre-flight checks. Now, this aircraft philosophy is really, really important to how we fly. And that's because when you fly an aircraft, you can fly it very often with really good unit economics. Your costs to fly an aircraft are much, much better than flying something like a rocket, because you use that hardware over and over and over. And when you do that, you can amortize the cost of that hardware over many, many flights. And so you bring the cost per flight substantially down. So start off in the hangar, start off with pre-flight checks, make sure the aircraft's all ready to go, all fit for flight. Get into payload integration. So just like any aircraft, we have our cargo area essentially where we load the payload into. We can connect it into the aircraft systems there so that you can have telemetry coming down from the payload in real time. You can control the payload in real time. This is another really nice thing about our system compared to more traditional systems where generally getting that payload during launch and during the flight isn't possible. Then once payload's all ready to go, then we get ready to deploy to the runway. So you see the aircraft's out here about to be towed out to the runway by our support vehicle. Then get on the runway, get through all of our final takeoff preparation, ready to go for flight. So then all set up, ready for takeoff. Then off we go, take off, get into our climb, start departing away from the runway. Now, a big part of preparation for our flights is working with our customers to understand what is the mission they want to do, what's the flight they want to do, what's the profile they want to do, how high, how fast, any particular maneuvers, any particular locations, that sort of thing. So once we've taken off, generally for most customers, we end up they want to go pretty high and pretty fast, so we get into a near vertical climb very quickly. Yeah, really get moving. On this particular flight for Cal Poly, so apogee was 37,000 feet, so not too high by any stretch of the imagination compared to rockets and things like that, but certainly a lot higher than you can typically get on more conventional aircraft. And then after apogee, get into the rest of the mission. Again, flying the profile, flying the test points, trajectory, and so on that the customer requests. And then again, just like an aircraft, once we're done with our mission, we come back, we join the circuit, get onto downwind, then base, and then onto finals, set for landing. And then land and stop, and then send out our recovery vehicle, pick up the aircraft. And then, within really a matter of minutes after our flight, we can get the payload out of the aircraft, get it back to the customer, and start doing data analysis. So this is another thing which is really nice about this reusable platform, and quite a paradigm shift compared to more traditional forms of things like sounding rockets and so on, is that you can get the payload back very, very quickly. You can look at your data, you can see how things went. And then, so not only do you get that feedback really quickly, but because you've got the payload back, if you want to make a few tweaks and then go and fly again, or you just want to go and fly again because, we all know good science, you've got to do a test more than once. It makes it very, very rapid to go through multiple iterations, as well as just get multiple test points and really, really make sure you've got valid data. So that's it, completing a flight, a bit of a shot of some of the team here who've helped work on this as well as part of the wider company from Dawn Aerospace. So just while I'm on that, so the main part of the company that's relevant today is our spaceplane part of the company that flies out of our New Zealand location. We've got two locations in New Zealand when we fly, and then as I'm sure you will have heard, we've just recently signed a deal with Oklahoma Spaceport. So we'll be delivering the next version of our aircraft, the Mark IIB, to them in 2027. So outwardly, the vehicle looks very much the same. It's the same geometry, essentially, but on the inside, it's a completely different machine. So substantially upgraded engine, a lot more propellant, much higher payload capacity, and roughly 4 times the performance in all the metrics that matter compared to this Mark IIA aircraft that we're presently flying. So 4 times the altitude capability, almost 4 times the speed, substantially larger payload, just a much, much more capable aircraft in general. And so way more ability to do things like microgravity, Earth observation, new system testing, supersonic flight testing, things like that. But then as well, Dawn also has another part of our business is our satellite propulsion part of the business. And that's something so we've been flying our hardware in space on that since around 2020, I think it was 2020 or 2021. We've got a bit over 160 engines in space now on dozens of satellites across dozens of customers. So really building up a lot of really good heritage with that technology as well. But no mission's complete without a mission patch. So here we see our patch for Cal Poly. So yeah, another really cool part of things. So lastly, I just wanted to talk about quickly about the process of how we conduct these sorts of flights and so on. And it's not just about the technology. and in our case, the aircraft that we fly, but also the infrastructure is so important, and really grateful to be part of the Global Spaceport Alliance in terms of expanding our options and our ability to fly from a range of locations globally. And again, going back to the aircraft philosophy, another one of the real beauties of an aircraft is there's so much infrastructure available globally to operate an aircraft. And that just means our ability to scale and deploy this globally with a range of partners is just substantially better than something like a rocket where, there's quite limited ground infrastructure, there's quite limited airspace infrastructure and things like that for operating rockets, whereas aircraft is much, much less constrained. And we really do operate this like an aircraft. So the next important aspect to consider is all the regulation and how you fly. So we work very closely with our Civil Aviation Authority in New Zealand. That's our equivalent to FAA. And that's who we get our license through, our CAA. And it's really important that we work with them to establish how do we operate this thing as close to how you operate an aircraft as possible. So in terms of how we fly it, we have a crew that operates this very much like an aircraft. So often we get asked, like, how does the plane do this, or how do you do this? And the answer is almost always, or rather, the general way to think about this is, however a conventional aircraft does it, it's just that the pilot stays on the ground and it has a rocket engine, not a gas turbine, something like that. So the crew talks on the radio, the crew talks to air traffic control, we talk to other aircraft who are flying, we sequence in with other aircraft who are flying. We have ADS-B transponder on the aircraft, so other aircraft can see us on their traffic awareness systems. We can see other aircraft on our traffic awareness systems, and so on. And this is a big part of what enables us to fly very, very regularly, to have a license that allows us to fly very regularly. It's what allows us to, we've done multiple flights in a day. It's really just a very transformative experience and capability that we bring, not just in terms of the technology, but also how often we can fly it, how easily we can fly it, how repeatedly we can fly it, and also just how cost effective it is.
Excellent. That's great.
Yeah. So
Super introduction. Thank you, James. Okay.
Yeah.
Other speakers include Dr. David Alexander, Director of the Rice Space Institute. So let me pass it over to David.
Thanks, George. So what I wanted to do just to get us going is I just want to give some sort of just a couple of slides to give a kind of big picture down, but with some examples of what we're doing here at Rice University in Houston. One of the things when we talk about space, I think I talk about these 4 I's as a kind of encapsulating, the kind of excitement that we do across the world of space, whether it be looking at the universe, looking at the Earth, or trying to build, stations and so on. And it's the kind of information that space provides, the innovation that we need to and we just heard about some innovation, right, from Dawn. And then how we imagine the future and the things that we need to go forward. And then basically to bring, and this is the educational part as well, is to bring that inspiration into the classroom and into the workforce so that we can get people excited about contributing to our industry. And I think that's one of the elements that is basically universities provide. And so I think the, whether it be a research university or a community college and so on, the whole range of getting people to think about their role in the space industry, I think is something that we're all passionate about. And I think when it comes to the spaceport side of thing, that gives us another opportunity to expand on that. A couple of things we're doing at Rice. I won't go through this in great detail, just save time for other speakers. But, we have the traditional programs, right? It's a standard kind of thing. But there are other things that come in and are particularly relevant to the space world. I used to work at Lockheed Martin, and my standard, many of you may have heard me say this before, as a scientist, we'd go in and talk to the engineers and tell them what we wanted to do. And as soon as they stopped laughing, they would tell us what we could do, right? Mass, power, volume, cost, all the kind of limitations. And so when I came to Rice, I created this professional master's program to bring our students into that, to create a scientifically literate engineer. Why we go to space, to observe, to do stuff, and also create an engineering literate scientist so they understand the limitations and what goes into that kind of design effort. But then combine that with the kind of project management skills and so on. And I think these are the kind of programs. Rice is small and we have a small program, but it's growing. And internationally, we have a number of folks coming in. And so I think people are interested in having that, especially small companies. They want good engineers rather than just necessarily an aerospace engineer or a thermal engineer or something. So that's something that we've been building up over the last few years. One of the key elements that's happening in lots of universities is engineering design. And, we have an actual program in our engineering school where we work with industry to bring real problems into the classroom. And so the students put their own teams together. They select the problems that they want to do, and then they kind of work non-stop almost as part of their capstone project to work on those problems coming in from industry particularly. On the entrepreneurship side, one of the things that we're doing, my friend Annika's in the audience here, the vice consul for the Swedish government here in Houston, as well as her day job. And we are working a lot internationally. We just created the Texas-France Space Hub where we bring startups and small companies to Houston for an extended period to engage with the industry here. And we're running that through the university because we're also wanting to add a research component to that, and that's where the academic institutions come in. But these are companies, and this intention is to bring that international, so the kind of broad solution set. We don't have everything here in the United States. We might think we do, but we don't. And so having this innovation and these ideas coming from around the world into the US component, where is arguably, and maybe not arguably, but definitely the biggest market when it comes to commercial space. And Houston is a great hub for that. So we're growing that. We're talking with several other countries about this, and we're holding a number of international events. And so that allows our students and our faculty to engage on the entrepreneurship side with academics and industry partners from around the world. And then just a direct connection on the education side, the student engagement, apart from having a rocket club and various other student activities, we partner very closely for years now with the Houston Spaceport. And one of the things we do is essentially a monthly lecture, public lecture. Our next one is next week, and we will have Starlab. Tim Copra will be speaking about as we think about commercial LEO. So there's lots of ways universities can engage, and lots of different things you can do that takes on the strength. I'll leave my friends from San Jacinto to talk about how they're doing what they're doing in partnership with Rice and others in the Houston Spaceport. But I just want to finish with why we're sort of having to think a little bit differently in the educational world. Our students are really looking for they want to solve real problems. They don't want to just come in and learn what somebody did 2,000 years ago in Greece, right? But they want to actually have more hands-on. They want to learn more. They want to cross disciplines, and they want to solve real-world problems. And so most of our world in terms of the academia is expanding these offerings to accommodate that and to really train our students into how to think and how to solve problems. NASA, of course, is working with student challenges and providing opportunities for these students to be innovative, and we have to support that at the universities. Obviously, I've mentioned this earlier about interdisciplinary graduates, people who can understand the business as well as the engineering. And then the spaceports allow us to, kind of have this easier access to the space industry. So we need that partnership. We need the industry people in our classrooms, even if it's just to give a seminar, and so on. And then, as I said earlier, it's that kind of multifaceted. Some of our students in this professional master's program go out and start their own company. So it helps to give them a little bit of a leg up if they can develop some of these business skills. And one of our students, for example, did business development at the Houston Spaceport a few years ago. So this is the kind of thing that we're trying to do at the universities. And of course, that's where Spaceports come in. I think giving them the opportunities to see the business world as a whole as well as the technical component. And I think we're kind of excited, particularly being in a place like Houston where there's a lot of this going on with the Texas Space Commission. I also saw Laney's on the call. I think there's a lot that the universities can step up to do. We need to adjust how we do things a little bit. Translation of technology rather than just keeping it in the lab. And I think these kind of conversations are really important, and having the industry and the academia come together, which again is a strength of the GSA. I think that's really important. So again, just some high level thoughts, coming from our side, and I'll start with that, and we can move on to our next speaker.
Excellent, thank you, David. So in addition to Rice, one of the academic institutions that has been very active in working with the Houston Spaceport is San Jacinto College. And today we have Dr. Sarah James, the Associate Vice Chancellor, who's in a car. So forgive us a little bit of the background noise, but I think we can hear you just fine. So over to you, Sarah.
Okay, well, thank you so much. I really appreciate this opportunity. And working with David at Rice University has really been a highlight of the way we work with the Houston Spaceport. In fact, when we first got started at the college, there was a group of us, including the Houston Spaceport personnel, the City of Houston, the Bay Area Economic Partnership, and Rice University, represented by David. And we went around the country, even went to Scotland, to see how we could best fit and accommodate the industry in the Houston area. And in particular, the Houston Spaceport is the only urban spaceport in the United States, and it has been approved for horizontal launches where others can do vertical launches. We can also do we can't do vertical, but we can do horizontal. And so in working with our local companies through the connections we've made by virtue of the Houston Spaceport, we learned that the community college really needed to focus on technicians in the advanced manufacturing area. And so we work with our local industry partners to find out, to educate and train the workforce that they need to keep us going and to keep the Houston space economy going. We had 18 of our students work with Intuitive Machines for their first lunar lander. We had even more work on their second lunar lander as the Intuitive Machines industry grows. We also have, Axiom Space, with whom we work with, and several others. But with the Houston Spaceport, we also have what's called the HS-CREW, the Houston Spaceport Center for Research, Education, and Workforce. And that is a college and university organization led by the Houston Spaceport, and it includes San Jacinto College is the only community college, but we have University of Houston, we have Texas A&M, we have Texas Southern University, and last but not least, our best, Rice University. And we meet every other week to discuss what is out there that we need to address and learn how we can best address it as a unit, or who needs to do what. We also work together as companies from our delegations from other countries come into the Houston area. The educational systems are always involved in those visits, because as companies from other countries such as Italy or France, when they come over, they're going to need a workforce. And they get workforce programs. And so it's very important, Trace, what they can, beyond just the technique to start with the universities. As I said, San Jacinto College and Rice University work well together because we have students who can start off as a technician at San Jacinto College, then they can go into a technician engineering program. From there, they can articulate to a bachelor's degree at the universities that we have in our area. And from there, they continue and can even go into Rice and go through the Rice Space Institute. When we collaborate with other countries, we also show that pipeline that starts with the technician and can grow their employee base up through the master's and doctoral degrees at the local universities, particularly at Rice. Our programs at the college include composites, structural, basic engineering and electronics, and quality. We have 3 nationally recognized certifications so that students that complete our programs can move to other centers and get very good jobs because they have these national certifications. I would like to introduce and turn this over to Clint Harris, who is our program director, to share just a little bit about our programs and certifications, and he will also share with you some of the other things that we do with our K-12. So Clint, take it over.
Good morning, everybody. As Dr. Jane said so well, we have a great connection with all of our industry partners, whether they are manufacturing or education. And we base our courses off of the need of our industry partners. As Dr. Jane mentioned, structures, composites, and electrical are the 3 biggest demands that our industry partners have stated. And as that changes, we modify that. We have the certifications from Space Tech, which is a CERTEC certification in aviation structures technician, composites technician, and basic electrical electronics technician. And we're also working with IPC for 610, 620, and the NASA J standard, which in lay terms is basically wire bundling, wire cabling, wire terminations, and soldering standards that we're bringing out to our industry partners. As we continue to develop that, we work with our partners such as Intuitive Machines or Axiom to offer courses that are customized specific to those companies, or internships and apprenticeships. And we have a great working relationship with the Texas Workforce Commission to where we can help potentially offset some of the costs for our industry partners for their training needs. Companies include, like I said, Intuitive Machines, Axiom, Collins, SEIC, KBR, the list goes on and on. And we just continue to move forward with our whole industry partners. I think that's pretty much everything. I think we covered everything.
Great.
It was just so big, we missed a lot.
Okay, thank you, Clint, and thank you, Dr. James. We really appreciate that. Next up, we have Liz Koenig, who's the CEO of Teachers in Space. Liz.
Okay, great. So Teachers in Space began as a project of the Space Frontier Foundation, and we were initially funded with a NASA cooperative agreement in the 2009, 2010. And in the beginning, what we were doing was offering professional development for teachers, K-12 teachers, to help them understand what the coming commercial space industry was going to mean in terms of jobs and access to space, science, what we could do with it. We used to run our programs either at Embry-Riddle University or at the Mojave Spaceport. Those were the most common places. And we began with balloon launches. By now, we are teaching teachers, and then they work with their students to build 2U CubeSat type experiments, which we can fly suborbitally with Blue Origin. And we have had 3 orbital launches of CubeSats that we've built. We've put those up with Firefly. So the rest of my slides talk about the impact of what we're doing now, because we continue to provide professional development for teachers. But now we're able to do it at Challenger centers. We're able to do it at some air and space museums like Intrepid. We've taken it to high schools. And we are getting teachers who already know how to work with Arduinos. And so we're teaching them how to build experiments with Arduinos and sensors, how to collect data, and then how to do that with their students. And so the exciting thing for the teachers and students is that they are designing and building the experiments, and it's their data that's coming back to them. We're getting good responses from being able to send our 2U experiments with Blue Origin, and this year they have begun taking those experiments on the astronaut flights, which is super exciting for us. We've been sending teachers with experiments. You can see a team here up on 0G flights, and you can see Jim Cool on the left, who's our curriculum director and is a former NASA educator, astronaut trainee finalist. He's checking his wristband where he's got the parabolic instructions, what it is that the team members are supposed to do on each of the 30 parabolas. And we're really excited to be getting close now. We believe that in the next 12 months, maybe even this year, we will, it's very likely, we're very close to getting our first teachers up to space. So we're super excited about that. And I'm really happy to see so many spaceports coming online and to see what's going on with the universities, because when we started, it was mostly asking NASA what they were doing and then talking to some of the early suborbital companies. X-Corps was a big supporter of teachers in space, and trying to find ways to share that with our teachers and their students. But now the companies themselves are giving us flights, helping us with the technology, sending people to help talk, enabling us to bring teachers occasionally to launches or to integrations for launch. And so it's making space real. It's making space something that teachers and students can do rather than just watch on television. And I'm really thrilled to see what's going on in the industry these days. There they are. Okay, yeah, so this is really important. What we found is because the teachers are getting their hands on these technologies, we do typically 4-day workshops, 2 days of Arduino and sensors, and then on day 3, we do a balloon launch, and we get that back, and we take the teachers with their experiments typically up for a glider flight. And if they want, they can take the controls of the glider. And so then the 4th day, we spend working with the data from those 2 flights, from the glider flights and the balloon flight. And also now we are giving them some really simple ground station equipment so that they can track and receive signals from orbital satellites. And so we're bringing that into the program as well. So we get really high ratings on how much they enjoy it and how much they learned and how much they would recommend to a colleague. The great thing about focusing on teachers is that with over 650 teachers trained, we're in the tens of thousands of students reached, because those teachers keep going every year. And a lot of the middle school teachers now are a STEM teacher for an entire middle school. So that teacher can impact hundreds of students every year. Okay, and the next slide shows some of the kids, high school in the upper left, middle school as you move to the right, working on building their classroom experiments, the kind of circuitry for a popular 2-dosimeter experiment that came from a high school in New York. One dosimeter is wrapped in radiation protection and the other isn't. And so the teachers build this and they can chart the results. You can see red and blue. The red in the graphs is the unwrapped. It sees more radiation than the wrapped one does. And it's really interesting to compare the different charts. The one on the upper right is from a balloon. It goes up, it comes down. And the one in the lower is from a long duration stratospheric glider flight with the Perlan project. So there's not a lot of change in altitude in that one, but you still see the difference in the data. Okay, next, flying in the upper left, that is the egret, which is the stratospheric tow plane for the Perlan glider, which has set records over 70,000 feet in altitude, carrying, these are the 1U cubes that the teachers and students build. There's a balloon mission happening. Here's our team for our most recent 0G flight. That one went out of Kansas in May. And some of the things we do with those cubes, we put them Velcroed to the wall of the plane on 0G. Then they have tethers so that we can take them off and see what the difference is when they're on us floating free. We keep some in the payload locker, and then you can compare the data from all of that. And then the internals of the 2U, more about what we do on 0G and the ability to compare the data from these different but related cubes, and also doing some biomonitor testing for the impacts on our bodies as we're working in 0G. And then the next one, this is our ground station Rocco in the lower left when we are dealing with our orbital satellites. Above him, integration at Firefly, putting the 3U satellite into the deployer. And to the right is the satellite with its tape measure antenna and its solar panels. And then, yeah, this is when Blue Origin gave us our first launch on a human flight, which was April 14th of this year, that flight that was all women. Lauren Sanchez asked if she could take one of our experiments. And so we gave her the 2U that we had previously flown on a payload flight. And she was able to put that, there's a storage space under each astronaut seat. So she took that back to space for us and returned it to us. And then we had data with astronauts as opposed to without astronauts. And then she got on a Zoom with a lot of the students from New Mexico and Maine who had contributed to the design of that experiment. And that was really, really well done. She took a lot of questions from the students. They were very excited by that opportunity. And then she gave us another launch. So now we've had two. And that means that the next thing, what we're working on now, is to be able to get our teachers up on suborbital flights with those classroom experiments. Okay. And the number of people and entities that we're able to work with now just keeps expanding. And I can't wait to see this slide have a lot more spaceports on it by next year.
Sounds great.
Thank you.
Thank you, Liz. Okay, and our final speaker is Matt Voss, who's a co-founder of Near Space Education. Matt.
Yeah, thank you. Appreciate that, George. And thank you, Elizabeth. Fantastic to hear all the impact you guys are doing. So yeah, I'm with Near Space Education, sharing on behalf of Near Space Education, also working with Near Space Launch. So yeah, talking about spaceports thrive by strong academic ecosystems, and just how do we expand our ecosystems, what we're about here today, and just how do we do that. So I'll be also sharing, similar to Elizabeth, on just more the academic side, and just how do we get people inspired and jumping into that model here as well, and the rest of the team that was sharing prior to that as well. Just how do we do that? So let me just click through the slides here real quick and see if I can get them to work. All right, here we go. So yeah, so Near Space Launch. So Near Space Education grew out of a commercial company called Near Space Launch. They have over 1,000 systems on orbit, 100 satellites on orbit now, and continue to do that through commercial and government. But Near Space Launch grew out of a university called Taylor University 10 years ago. And so continue to have that mission for education. How do you work with that? Make collaborative integration, because a lot of innovation happens when we have places like a spaceport to collaborate at and work together. And so the approach of NSL has always been an iterational approach of just take something simple and go more complex over time and see how it grows. And a lot of those times having different groups and parties work together. So a lot of different partnerships, over 100 different space companies they worked with. And so from there, NSC was born, Near Space Education, in 2020. So not too long ago, 5 years ago, but kind of growing out of 20 years of experience with NSL's 10, and then the founders were professors. How do we take something simple and make it more complicated? So, you know, students, there's been a good initiatives to try to build full-on CubeSats, but why don't we start earlier which has been strategy shared here, is like, let's start with Arduinos. Let's start with, simpler systems that teachers are working with to start teaching with. And then do high altitude balloon launches, then do ThinSats, which is a simpler version of a STEM satellite, and then also a full CubeSat. So more of an iterational approach. And so that's where NSC really stepped forward, was saying, let's continue to partner with a lot of different locations to find places to gather and create places for kids to be inspired, equipped, and impacted. And so that's kind of the mission statement for NSE, is to inspire, which is very similar to the Spaceports, of how do we inspire groups together. And so this is a great place to draw kids in. It brings in the crowd of students to get curious, and we love curiosity, and getting them to think about how can we get involved. But then we also want to equip them. And so that's something that we see, that, with these balloons, that they first are a great place to partner, like the Alliance here. These balloons go to 100,000 feet. So you see the curvature of the Earth. You get to see some really cool stuff on cameras, but also your sensors that was just shared about. But also you get a place to data collect there. So you're getting some real science that can be pulled in, or it can be a pretty simple process there. So we're talking some great high altitude experiment to the top 1% of the atmosphere that you can launch from Spaceports. You can launch from some places there to really engage the community academically, from K through 12 through university levels to, testing actual space partners there with. So it can be very simple. They sometimes have some simple tests with fly a pizza, or they can fly Arduinos. They can make a custom payload and make it very complicated. So it's a very scalable program, and I think that's why balloons are such a great way to work with students with this. And you can actually track these things and know exactly where they land. So with our systems here, we're trying to also tie them into space programs. So the same radios that you use on these balloons, we've tracked about 500 of them now. Then we retrieve them as well. And so they actually use the same comm radios that would be on orbit. So it's a great way to get iterationally people used to going to space. So this is just some fun data that students are collecting. They get to do analysis on. They get to watch as well the takeoff of these, and just there's their experiments. They retrieve it. Parachute brings it down. Another program that we've started is the Dream Big program. So launching these, finding collaborative locations to create an ecosystem of space. So we're helping through our commercial group, Near Space Launch, build 6 satellites that will then go to the universities. They're building experiments. They put them on board. And they also do local outreach in their ecosystem. So we're collaborating with different groups like this to find ways to inspire them. So these 6 will actually launch on the Transporter 16 here in February, 6 universities. And so this is a pilot program that is wrapping up, and we're looking to scale this to national and global efforts here. And so we're excited about that to inspire. So this is balloons that can inspire high school K through 12, equipping them with spacecrafts for universities, and then impact. And this can change as well, but this is just a neat pilot program that we're wrapping up and going to be scaling out. So that's kind of a quick statement of what we're doing there, and just seeing the way that we're seeing students get inspired, we're seeing students getting equipped, and then hopefully we can connect them to industry and land them in roles at Spaceports ecosystems and other places like that. Because there's a big demand and need, as we all feel, I think, for STEM and education locally, regionally, and globally. Just how do we get kids excited about the uncertain future and just equipping with the best tools? So, and that, I think Spaceports are a great place to do that. That's why we're part of the Alliance, and excited to see where things go from there.
Excellent. Thank you, Matt. So I don't see any questions in the chat right now. We covered a lot of different topics. Let me just ask each of our speakers, if they could, to just take about a minute and highlight what are you most excited about or most looking forward to in terms of next activities over the next 12 months. And so, James, if you could, you talked a little bit about this, but what's coming up in the next 12 months that you would like to reiterate to the audience today?
Yeah, well, I mean, immediate thing right now. So we've just had a press release go out for our recent flight with Cal Poly. So I'm really encouraged the whole audience to have a look on YouTube for videos on that and our press release, get a bit more info on that. But again, we really want to operate this as much like an airline as possible. And so we've got upcoming flights over the next year or so. I'm always happy to talk to prospective customers who would like to fly a payload. And then the really big thing in the current pipeline is getting ready for our aircraft to fly out of Oklahoma. So that'll be a 100-kilometer altitude suborbital capability, really, really nice microgravity capability on that, ability to fly payloads domestically in the US, and certainly can take international customers to who come to Oklahoma as well. So yeah, that's a super exciting one.
Excellent, thank you very much, David. What's coming up for Rice in the next 12 months?
Well, I think one of the things that we're really excited about now is just the sheer interest of the international community. Obviously, we're all excited in Texas about the Space Commission and what they're going to do in the next couple of years now that they've got their marching orders, their funding and stuff for the next biennium. So I think there's a lot that's going on. We're going to see a lot of interest in Texas and in Houston, and taking advantage of that, I think, in terms of programs that we're working on and conferences and so on, I think is really good. And then, I get to go to New Zealand in a couple of weeks, so that's exciting.
Very good. Okay, Dr. James, how about from San Jacinto's perspective? What's coming up that you're excited about? You're on mute now. Excuse me. Yeah. Dr. James.
Okay.
There we go.
Okay. Yes, one of the things that we're really looking forward to is developing an apprenticeship in aerospace technicians, and several companies have come to us and want us to do that. So we're excited to maybe have one of the first ones, particularly in Texas. We're also looking forward to the opportunity working with the Texas Space Commission and getting a grant from them to work with other community colleges in Texas. And then we're also getting ready to start a couple of new programs at our space center, our Edge Center right there at the Spaceport. So we're looking forward to doing quite a few different things and going in different directions there at San Jac with the space community.
Excellent. Thank you very much. Clinton, any additional insights for San Jacinto?
James covered almost all the points already, which is great. The other one is our collaboration with Johnson Space Center and our teacher externship. Some of the companies at Johnson Space Center do a teacher externship, and we are one of the co-hosts for the externship that they do every year, and we're excited to continue to do that this upcoming year as well.
Excellent. Thanks, Clint. And Liz, you mentioned some of the things you've got coming up, but just to reiterate, what are you excited about for the next 12 months?
I'm really excited that we are getting close to getting our first teachers up in space. That has been our goal since we started 15 years ago, and people don't laugh anymore, right? People are actually helping us get ready to do that. So that's the big news. And then additionally, we just keep expanding. So we have been working with a couple of states in particular, but now we're starting to get interest from school districts in new states. So continued expansion and growth and more experiments and more data back.
Outstanding. Thanks, Liz. And Matt, what are you looking forward to most in the year ahead?
Yeah, thanks for asking. We're excited about a couple different things, but I think we're scaling up a lot of production of just a lot of technology at our groups here to just provide that to the community and just help strengthen other ecosystems. And so from the balloons to spacecrafts, and how do we just get more kids excited about what's going on. So I think there's the dream big goal of globally doing more. So we're launching these 6, it'd be neat to do that on a global scale. There's ways and avenues that could be happening soon. So we'll see how that all works out. But excited just to keep finding new partners and seeing where the new people we get to meet through the whole process. So it's been great.
Excellent. Thank you. So we're coming up on the end of our time here, but I want to thank our speakers again, James Powell from Dawn Aerospace, Dr. David Alexander from Rice Space Institute, Dr. Sarah Janes from San Jacinto College, along with her colleague Clinton Harris, Liz Kinnick, CEO of Teachers in Space, and Matt Voss, co-founder of Near Space Education. We will have a recording of this panel if you wanted to listen again or have some colleagues that weren't able to tune in today, and that should be up within the next week to 10 days on the GSA website. Also want to thank our sponsors, RSNH, Merrick, BRPH, Parsons, ITA, HDR, and MITRE for all their great support, and remind folks of upcoming activities, including our International Spaceport Forum in Sydney, registration for Commercial Space Week in Orlando in January, and our upcoming webinars. Check out the website for more information and for how to become a member if you're not already part of Global Spaceport Alliance's membership list. So thanks again to everyone. Appreciate you tuning in today and hope to see you again soon.